Hey everyone, you may have noticed in geometry that we have these lines, and lines also show up in algebra, and so we're calling this the connection to algebra unit. As we're taking a look at some shapes that are actually plotted on a coordinate grid, and we'll eventually extend that to some of the shapes we've studied like rectangles and rhombuses and trapezoids and other kinds of quadrilaterals. But we're starting off with slope, midpoint, and distance formulas, so this will be a bit of a review. But we do have a bit of a twist as we're going to be using these formulas with variable coordinates. So we'll see that in a moment. Here we're starting off with just a little bit of an introduction to slope. We'll be using this more tomorrow as we write equations of lines, but it's just an introduction today. Further down the page we'll be taking a look at the actual calculations using the formulas for slope, midpoint, and distance. So you can see I've got this already prepped here. Slope is a kind of measurement, right? It's measuring the steepness of a line. So you might have a very shallow line or a very steep line. How steep is it? And that's what slope will measure for us. If we have a positive slope, that means the line will increase as we go from left to right. Now I have arrows on both sides because the line goes on forever, of course. But you can see it is going up, 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 up. The negative slope will go down the page as you read from left to right, so down, down, down. The zero slope, that's your horizontal line because it has zero steepness. And undefined slope, that'll be your vertical line. All right, so we're going to be taking a look at those in our calculations in a bit. If we were to find the slope just looking at a graph, well, if you connect the 2 points, it doesn't really matter if you go from point A to point B or B to A. I'm going to do it both ways so you can see how this works out. It helps if you create a triangle. From the endpoints of A and B, create a horizontal side, create a vertical side, and you have a right triangle. So for example, if I go from A to B, I'm going to be traveling leftwards along this side and then turn the corner and then downwards along that vertical side. So the distance is 1, 2, 3, 4, 5, 6. We refer to that as -6 because we're going to the left. And then down 1, 2, 3. So -3 for the downward movement. So if you're thinking about your slope, slope is defined as being the change in height, and that's the rise, over the change in horizontal distance, that's the run. So you can see that we have risen or fallen 3 units. And then we have transitioned horizontally 6 units down. So -3 over -6 turns into a positive slope. Yes, this is a positive slope. You can see it's going up, just like what we had our sketch over here. Now, if we had gone from B to A, we could go up and to the right, or we could even create the little triangle underneath the line. Either one is fine. So I'm going to go from B to A along this triangle underneath. So we're going to the right 6 units, so it's a positive 6. Turn the corner, we're going up 3 units. And so if you're thinking of your slope, which is rise over run, well, the rise is the vertical distance, which was +3, and the run is the horizontal distance, which is +6. You get the same result either way, so it doesn't really matter whether you go leftwards or rightwards in finding the slope. Let's do one more. Here's example 1, taking a look at part A. We're going from point B to point A. Create the triangle, either above or below, doesn't matter. And then we'll count that distance. So I'm going downwards from point B, 1, 2, 3, 4 units, and then rightwards, 1, 2, 3, 4, 5. So our slope, use the letter M to represent that slope. The vertical change over the horizontal change, that fraction doesn't reduce. So that's a negative slope. It's falling as you go from left to right. So that's a brief introduction. We'll be seeing more of that tomorrow. Now we're talking about these formulas. So here's your formula for the slope. Given 2 coordinate points, we can calculate the steepness by subtracting the y coordinates on the top and subtracting the x coordinates on the bottom. So when you're looking at these ordered pairs, use the comma to separate your x-coordinate from your y-coordinate. We have 2 different points, so that's why we refer to them as point 1 and point 2. That's why we might have x sub 1 and x sub 2, because those are your 2 different x-coordinates. We have y sub 1 and y sub 2. Those are your 2 different y coordinates. So that's what they're talking about here with the y sub 2 and the y sub 1. we're going to be subtracting those y coordinates. So I have a 5 and a 1. Subtract those x coordinates. I have a 1 and a negative 7. So 1 subtracting the negative 7. So be careful of your signs there. We are subtracting the negative 7. So 5 take away 1 gives us 4 on the top, and 1 subtracting the negative 7. Remember, subtracting a negative is the same as adding a positive. So 1 plus 7 is 8, and then reduce the fraction to 1/2. All right, so in other words, it's a positive slope. So it is increasing if you were to graph it from left to right. Let's jump over to part C and part D. Again, find the comma there. That separates your x-coordinate from your y-coordinates. And here's our slope formula. The y-coordinates are 9 and 3, so 9 minus 3. The x-coordinates are 4 and 4, so 4 take away 4. So this gives us a strange situation where we have a 0 in our fraction. And so we have to be careful trying to remember whether this answer is going to give us an answer of 0 or an answer of undefined. Now the nice thing is you can just type this in your calculator and see what it gives you. If I were to take that 6 and divide it by 0, notice that what it gives us is an error message, and that means you don't get a number. You don't get a 0 as an answer. This is the undefined slope, which sounds strange, but remember we said undefined slope is a vertical line. So that means you have lots of vertical change and you have no horizontal change on its graph. That's what you're seeing here. You have a vertical change as you're subtracting those y coordinates, but you have no horizontal change. All right, here's part D. Find those commas. They separate your x from y coordinates. And again, let's set up our slope formula. So y minus y, you have an 8 and an 8, so 8 take away 8. The x-coordinates are negative 7 and 6, so negative 7 is subtracting the 6. This time we have a 0 on the top. So again, you could type that in your calculator if you're not sure, but in this case the answer is 0, and that represents your horizontal line, right? So the 0 slope means that you have a horizontal line, and the undefined slope means that you have a vertical line. So use those two to help you remember which is which. All right, so we're going to turn the page here and take a look at the twist. The twist being we can use this same formula using variable coordinates instead of just numerical coordinates. Here I've turned to the top of the next page. Examples E, F, and G. These are the ones now where you have these coordinate points, but you'll notice they have variables in them. They may have a coefficient in front of the variable, and if not, remember that's just a coefficient of 1. So this is 1a, this is 1b, this is 3a, this is 7b. So here's the slope formula just for easy reference, so we don't have to keep changing from front to back. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's do that here. Now remember, look for those commas. Those commas in your ordered pair are separating your x coordinate from your y coordinate. And here's our slope formula. All right, so we want to subtract the y's on top, so we have a 7b and a 1b, so 7b minus 1b. And the x is on the bottom, so 3a and 1a, so 3a minus 1a. And then you look to see if you can combine like terms. 7b minus 1b is 6b, and on the bottom 3a minus 1a is 2a. So yes, we can combine like terms like this. We're almost done, but we always look to see if we can reduce the fractions. So you look at the coefficients. You also look at the variables to see if anything can cancel out. So yeah, 6 divided by 2 is 3 over 1. So you can write it several different ways. You could write it this way, for example, 3 over 1. b over a does not reduce because those are not like terms, so it's just b over a. So you could write it that way, or you could write it as 3b over a, or you could write it as 3 times b over a, right? So that's our fraction reduced. So let's take a look at part G. I'm going to jump over to part G here. Take a look at This is a good example where now we have more than just one letter for the x-coordinate and one letter for the y-coordinate. Remember, the comma is your guide. You want to use that to help you determine what is your x-coordinate. So the x-coordinate in this first ordered pair is not just one term but two terms. It's a binomial. Right? It's an a plus c. All of that is in front of the comma, so that's your x-coordinate. All right, so let's set up our slope formula. All right, so here's my y-coordinates. We have a 0 and a b, so 0 minus b. Then the x-coordinates, we have a c, and then we're subtracting. Now remember, we're subtracting a bundle, so that means you have to wrap it in parentheses because it's a binomial to subtract everything in that group. So 0 minus b, remember that's just a 1 in front of that, so 0 take away 1 is a negative 1. So that's a negative 1b, or negative b. And then I'm going to distribute the negative sign here. So you have the c in front. Distribute the negative sign to the a, you have a minus a. Distribute the negative sign to the c, you have a negative c. We can combine like terms. You have a c, take away a c, so they turn into a 0c, which means you have the negative a by itself on the bottom. And then again, you take a look to see if the fraction can be reduced. You look at the coefficients and you look at the variables. So you have a negative 1 divided by negative 1. That turns into a positive 1. The variables are different, so they don't simplify. It's just that we end up with a positive slope of b over a. All right, so that's what we mean by variable coordinates. So notice we're not solving for a, we're not solving for b, we're not solving for c, none of the letters, but we're just showing how they relate to each other. All right, let's do now that with the midpoint formula, again with some numerical and then some variable coordinates. Here's the formula. Here's the traditional formula, capital M for midpoint, x sub 1 plus x sub 2 all divided by 2, comma, y sub 1 plus y sub 2 all divided by 2. Or, we've seen in this class another way to write it. We can pull the x's and y's apart and create two separate formulas for each one. You could do it this way, x sub 1 plus x sub 2 divided by 2. That gives you a result of the midpoint's x-coordinate. And then for the y-coordinates, y sub 1 plus y sub 2 divided by 2, and that equals the midpoint's y-coordinate. For these examples, I'll use the traditional formula, but you could use either one. All right, starting off with part A. Again, find your comma. That will separate your x-coordinate from the y-coordinate. And for the midpoint formula, now we are adding. We're adding up the x's. So we have a negative 7 and a 1. So negative 7 added with a 1, all divided by 2, comma. Now we're going to add the y-coordinates. We have a 1 and a 5. Combine like terms. Negative 7 plus 1 is a negative 6. 1 plus 5 is 6. And then reduce the fractions as your last step. And these do reduce, so there's our answer. So that coordinate is in the middle between those endpoints on a segment. So what happens now if we have some variables? Again, we'll do a couple of examples here. Here's part B. Right, so find the commas. That will separate your x-coordinate from your y-coordinate. Midpoint formula says add up your x-coordinates. We have a negative 7a and a 1a. Add up your y-coordinates, 1b and 5b. Combine like terms. So negative 7a plus 1a is a negative 6a. And 1b plus 5b is 6b. And then reduce the fractions if possible. And again, you're looking at the coefficients here. And then you would be looking at the variables in case the variables could be canceled out. But no, the variables don't cancel out. So negative 6 divided by 2 is a negative 3 in front of the a. And 6 divided by 2 is a positive 3 in front of the b. So notice that we had the exact same numerical values for these two examples. So we get the exact same numerical results. We just happen to have a's and b's with those values. All right, here's one more. Here's part C. Again, find your commas. Those separate your x-coordinates from your y coordinates. Midpoint formula says add up your x coordinates. We have a 0 and a 4u, so 0 plus 4u, all divided by 2. Add up those y coordinates. We have a 2w plus the negative 8w, all divided by 2. All right, combine like terms. 0 plus 4u is 4u. 2w, take away 8w is negative 6w. And then divide, or I should say simplify the fractions. So 4 over 2 becomes 2u, and negative 6 over 2 becomes negative 3w. So again, we're not solving for the variables. We don't know what u equals, we don't know what w equals, but the point is, if we were to abstractly represent them on a diagram, for example, then this would be representing the midpoint. All right, lastly, we have our distance formula. The distance formula is a little bit more complicated, not just with the formula, but some of the rules for simplifying, so we need to review that as well. So d for distance, of course, if we have points, because we're working with endpoints of a line, then we would be using the name of those endpoints and labeling this, but here for these examples, there's no name, so we'll just use d for distance. So it's the square root of, now we're back to subtracting x sub 2 minus x sub 1 quantity squared. And then we'll add to that. Now we'll subtract the y coordinates, so y sub 2 minus y sub 1 quantity squared. All right, so there's a couple of rules you have to watch out for when we are simplifying. When we are simplifying, we look to see if under the radical we have factors. Factors are things that are being multiplied together, like a times b. Notice there's no plus sign here. This is interesting because the formula starts with a plus sign, but as we simplify this, it might get to a point where there is no plus sign. That's good for us in terms of simplifying. If we have a multiplication, those are factors, then that means we can take the square root of each factor independently of the other factors. That's good. That will help us to simplify. Here's a couple of examples to help better explain this rule. All right, example 1 and example 2. Example 1, let's take the square root of 4a squared. And in example 2, let's take the square root of 4 plus sign a squared. Notice they have the same values. They both have 4s. They both have a squareds. But one has multiplication and one has addition. So if you have multiplication, that's what we see here in the rule, then that means we can take the square root of 4 independently from the square root of a squared. 4 is a perfect square, so the square root of 4 is 2. And then the square and the square root cancel out here, so the square root of a squared is just a. So the answer is 2a in example 1. But in example 2, you have a plus sign, which means you cannot use the rule. You cannot take the square root of 4 independently from the a squared. This cannot be simplified. And so we want to take a look at a couple of examples where we encounter plus signs or no plus signs in some of these problems. Let's start off with part A. All right, so here we have the distance of, once again, and identifying our x's and y's, look for those commas. All right, so there's your x coordinate, there's your y coordinate, there's an x coordinate, there's your y coordinate. The formula said let's subtract those x coordinates. So we have a 1 and a negative 7. So 1 minus negative 7. All of that has to be squared, plus sign. And then the y coordinates are 5 and 1. So 5 minus 1 quantity squared. So inside those parentheses, we want to combine like terms. So 1 take away the negative 7 is the same as adding a positive 7. That'll be an 8. That has to be squared. 5 minus 1 is 4. That has to be squared. 8 squared is 64. 4 squared is 16. Hey, we still have like terms, so 64 plus 16, it combines to 80. And notice what happened. We don't have a plus sign anymore. So the equation started with a plus sign, but now we don't have a plus sign, which means if we can find factors that are being multiplied to each other, then we can simplify this. A little bit of guess and check will help us figure out that 16 times 5 are the factors of 80. That means you can take the square root of 16 independently from the square root of 5. And the square root of 16 is 4. 5 is not a perfect square, so that remains a 5. So that's our reduced radical form. No decimals here, we're just reducing the radicals. So let's contrast that with part B. Again, here's your commas to separate the x-coordinates from the y-coordinates. So distance formula. I want to subtract my x-coordinates, so I have a 1a and a negative 7a. So 1a minus negative 7a, quantity squared, plus. Now subtract the y-coordinates, so we have 5b minus 1b. Combine like terms inside those parentheses, so 1a plus the 7a, that's a positive 8a. Now be careful, you still have to wrap parentheses around this because you're squaring everything to square both the 8 and the variable. 5b minus 1b is 4b. Keep the parentheses because you have to square everything inside. So 8 to the power of 2 is 64. A to the power of 2 is a squared plus sign. 4 to the power of 2 is 16, and b to the power of 2 is b squared. Now in the previous problem, we had like terms, 64 plus 16 combined terms to a single term of 80. But in our current problem, we have unlike terms because of the different variables, which means they don't combine, which means we still have the plus sign. And that means we can't go any farther. This cannot be simplified. It cannot be simplified because of the addition. All right, you try part D. I'll pause the camera and I'll come back and put the answer up here in a moment. See if you can work out part D.